Inscribe the quadrilaterals in circles. In the previous video, we saw the inscribed angle theorem. We now use the inscribed angle theorem to prove two more theorems. Inscribe the quadrilateral theorem and the angle in a semicircle theorem. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. Draw a circle. Mark the center point, place 4 points on the circle, connect them to form a quadrilateral. If any 4 points on a circle are joined to form a convex quadrilateral, then the quadrilateral is said to be a cyclic quadrilateral or inscribed quadrilateral. A quadrilateral inscribed in a circle, also known as a cyclic quadrilateral, is a quadrilateral with 4 vertices on the circumference of a circle. Inscribed quadrilateral theorem states that the opposite angles in a cyclic quadrilateral are supplementary. In other words, the sum of their measures is 180 degrees. For the quadrilateral given alongside, the theorem says that the angle A plus the angle C equals 180 degrees, and the angle B plus the angle D equals 180 degrees. We now prove this theorem. The main result we need is that an inscribed angle has half the measure of the intercepted arc. Here the intercepted arc for angle A is the red arc, so the angle A is half of the red arc. For angle C, the intercepted arc is the blue arc, so the angle C is half of the blue arc. The angle A plus angle C equals half of the red arc plus blue arc. The red arc plus the blue arc is 360 degrees. Therefore, the proof is complete. Find the values of the unknowns in the following. Opposite angles of cyclic quadrilaterals are supplementary, so x plus 87 equals 180 degrees. Y plus 98 degrees equals 180 degrees. X equals 93 degrees, and y equals 82 degrees. Y and 70 degrees are supplementary angles, so they add up 180 degrees. Y equals 110 degrees. Opposite angles of cyclic quadrilaterals are supplementary, so x plus y equals 180 degrees. Replace y with 110 degrees and so for x. X equals 70 degrees. It's always true. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Y is an inscribed angle and 130 degrees is a central angle. If a central angle and an inscribed angle intercept the same arc, then the inscribed angle is half the central angle. Y equals 65 degrees. Look at the cyclic quadrilateral. Opposite angles of cyclic quadrilaterals are supplementary, so x plus y equals 180 degrees. Replace y with 65 and solve for x. X equals 115 degrees. Angle inscribed in a semicircle theorem. This theorem states that an angle in a semicircle is always a right angle. To prove the theorem, we will draw a circle with its center at point O. We draw the diameter BC. A diameter cuts a circle in half, forming a semicircle. If a circle is 360 degrees, then a semicircle is 180 degrees. We now inscribe an angle in a semicircle, and we want to prove that angle BAC is a right angle. We see that the semicircle creates an intercepted arc that measures 180 degrees. Therefore, any corresponding inscribed angle would measure half of it. Therefore, the measure of the angle must be half of 180 degrees, or 90 degrees. In other words, the angle is a right angle. We should notice that the triangle formed by the diameter and the inscribed angle is always a right triangle, and the hypotenuse is a diameter of the circle. Find the value of the unknown in the following. The segment AB is a diameter, so the angle ACB is an angle inscribed in a semicircle, and it measures 90 degrees. The sum of the interior angles of any triangle is 180 degrees. Solving for x, we get 37 degrees. R, H, S, T, and U lie on a circle. Center O. HT is a diameter and MN is a tangent to the circle at T. Angle RTM equals 61 degrees. Find the following. MN is a tangent to the circle at T and HT is a diameter. So the angle MTH is a right angle. The angle RTH is 90 degrees minus 61 degrees. The angle RTH is 29 degrees. The angle HRT is an inscribed angle in a semicircle, so it is 90 degrees. The sum of the interior angles of any triangle is 180 degrees. The angle RHT is 61 degrees. The angles RST and RHT intersect the same arc, and if two inscribed angles of a circle intercept the same arc, then the angles are congruent. The arc RUT is 122 degrees. The angle RUT is an inscribed angle, and the arc RST is the intercepted arc. The inscribed angle is half of the intercepted arc. The arc RST is 360 degrees minus 122 degrees. The angle RUT is 119 degrees.